Now let's review the approach that consider the base, which called the approach number 3, referred to as IMPT or Independent Maximum Power Tracking. In this particular approach, each power source is programmed and controlled by a converter that programmed as a controllable voltage sink and follow the peak power voltage command. For the source number 1 is VMP1, source number 2 is VMP2, and source number 3 is VMP3. These independent peak power voltage command are computed or determined by independent maximum power tracking controller number 1, number 2, number 3. In this manner, the ideal peak power is achievable or approachable, since peak power voltages of individual power sources are continuously tracked. This slide shows the power versus voltage characteristics of approach number 3 versus approach number 1, which is between the base and the worst approach. The base is the independent maximum power tracking. The worst is the drawing equal current from Siri connected power sources. The curve shown in upper parabolic trajectory is the static power voltage characteristic of the base approach called IMPT. This approach offers the ideal peak power of 842 watts at the total sourcing voltage of around 102.5 volts. On the contrary, the approach number 1, which has the equal amount of current draw from the Siri connect power source, provide far low optimum power, only around 742 watts of peak power is achieved by the worst approach, and also show one discontinuity around 103 volts. This is due to the nature of bypassing diode that cause the weak power source to have a voltage clamp across the bypassing diode, which prevent the weak power source from further dissipate more power and promote the more power to be delivered by the two remaining functioning sources. Without bypassing diode, the parabolic curve shown in blue, the lower curve, have only single peak around 482 watts. As a result, the worst harvesting approach has only 88% tracking efficiency as compared to the ideal peak power of 842 watts. Advantage of the base approach independent maximum power tracking. And disadvantage of this approach can be described. Advantage is that the independent maximum power tracking control approach enables the ideal peak power to be obtainable as a summation of all variable peak powers being extracted from all power sources in the system. The disadvantage is the most control complexity.